Hi again. Uh, I'm going to solve for you another example. This time the example has a little bit more of features than the other examples that I solved before. This example has concentrated loads, concentrated moment. It has rectangular distributed load and has also a triangular distributed load. So basically the way I start this, and I'm going to solve this problem, by the way, by areas or by whatever method is the easiest for me. Remember, I don't care too much about what method you use if you explain it, but you have to dominate and know all the methods. There are professors that they are very particular about some methods. The first thing that I do always is converting, for the sake of calculating reactions, converting these forces, these distributed forces, in a concentrated force, and this is a rectangular force, which is 6 by 4, 24, and the location with respect to this point is going to be half of the base. If this is 6, this distance is going to be 3. And here you have a triangular distributed load, which is going to be 6 times 4 divided by 2, make it 12 kilonewton. And the application of this load is going to be 1/3 of the base from the right angle. 1/3 times 3 times 6, which is 2 meters. Then we have these supports. This is a pin support. This is a roller. You see the little wheels here. So if we call this A, let me use this pen. We use this like A and B, and this is going to be C, and this is going to be D. Then we'll have AY. We have AX, but I'm not going to even put it there because there's no horizontal force, so AX is 0, and BY in this case. And then we proceed to calculate reactions. And remember, when we have two vertical forces or two unknowns in one direction, it's very difficult, or it's worthless to apply an equation in that direction. So let's start with summation of moments at A equals 0. If we do summation of moments at A equals 0, and we start from this, you have to be very careful, because when you see this problem, a lot of people miss this force, because it was kind of blurred over there, but there is a force here, so let's remark it. So then we have 6 times 6, 6 the force, 6 the distance, acting in this direction, and this is the positive direction for me. I have a concentrated moment here, which is 20. Remember, one of the errors that people do says 20 times 6. No, this is a moment, it's already created. Now we go to this side, and to this side we have this force, which is the 24 force that we calculated, times the location, which is 3, and it's acting in this direction, which is negative also. And then I have this other force, which is By, times the distance, which is 6, and it's acting positive. And then I have this force here, negative because the rotation happens clockwise, and I say counterclockwise is positive. So negative 12 times 6 plus 2 equals 0, and then you solve for By, and By is 18.6 kilonewton. Now we can do summation of forces in Y equals 0, and when we do summation of forces in Y equals 0, then we get negative 6 plus AY minus 24 minus 12 plus 18.6 equals 0, and then we solve for AY, and AY is 23.3 kilonewton, and this 3 is periodic, like that. Okay, now start with our diagram. What is the first thing that we do with our diagram? Well, we have to start with a line at the beginning, line at the end, and then one line everywhere that it needs to be, where we have a support, where we have the beginning of a load, when we have the end of the load, a concentrated load, a concentrated moment. So this basically covers everything. Now there's a bunch of people that put a line here because they get confused with the same fictitious force that they created here for converting the rectangular or triangular load into a concentrated load. Be careful, because those loads are not there in reality. Okay, and then we place a horizontal kilonewton and another one for moment kilonewton meter, and that's it. Now once you have the reactions, it's not necessary, but it's very advisable to check the reactions. So let's check these reactions. How are we going to verify those reactions? We have to do summation of moments somewhere. I'm going to put these values here, 23.3, which is my AY, and 18.6 periodic, which is my BY. And then I will do summation of forces, summation of moments in one point. And that point that I'm going to select, try not to eliminate any value. So I'm going to use D. I'm going to do summation of moments at D equals 0 with everything, including the reaction that I just calculated. So we can start from here, and then we say this moment is 20. Then we have 6, the force, times 18. That's positive. And then this force AY is 23.3 times 12 in this direction. And then I have this force, which is 24 times, this is 3, this is 3, this is 6, 6 plus 3, 9, and it's acting in this direction, meaning positive. And then I have this force, 18.6, my reaction, times 6, and from the point D is acting in this direction, negative. And then I have this last force, which is positive 12 times, well, it's 2 from this end, it has to be 4 from this end, and that should be equal to 0. When we check that and verify, we get it. So 0 equals 0. That means that our reactions are correct, and now we can start with our process. The way we're going to start our process, as I told you, I'm going to do this method by using areas. And I can do this really fast, but I want you to copy little by little everything that we are doing. So the first thing that we do is get into the point, and we start at the point C for the shear. I'm going to write shear in one side and moment in the other side. Solutions, method of areas, and then I'm going to start the shear here and the moment here. Shear, point C. Point C. At the point C, the first thing that I see is a force coming down of 6. That means this is going to be negative 6 kilonewton. Then I go to my diagram. This is my 0, right? It's going to jump down up to negative 6. Here. Good. Let's go with moment now. Moment. Do I have any concentrated moment? Yes, of course I have. And remember, we say that when you have a concentrated moment, then you have this as positive and this as negative. This as positive, this as negative. Counterclockwise positive, clockwise negative. The moment that I have goes in this direction, which according to this is negative, and it's 20. So I'm going to start with negative kilonewton meter. That's this point here, and this is going to be a jump here, negative, down, up to negative 20 here. If you don't get the first part correct, the rest is going to be a mess. So be very careful with that. Now then I continue and I say, okay, I'm going to the span CA, and because I have no load, no vertical load anywhere here, there's going to be constant, and by that I mean that this negative 6 is going to continue constant up to the other end, which is going to be negative 6 also. That's what I mean. The moment, because I'm using areas, then I have this negative 20 here, and I have to add this area that I have in this other part. Well, that area is a rectangular area, negative, and this is 6, and this is 6. So basically I have negative 20, negative 36, which gives you negative 56. That is the value for the moment, and the units of course are kilonewton meter. So from here it's going to go to negative 56 kilonewton meter, and because this is constant, then it's going to be straight line. I'm sorry, it's going to be a straight line but with negative slope because the area is negative. So it's going to come like that. So from these points, between these 2 points, it's going to come a straight line, straight line there. And then we go to the point A, and we say, do we have any concentrated force acting at point A? Yes, we do have a concentrated force. And before I have negative 6, and now I find this load of 23.3 periodic going up, which means this is going to mean a jump in this direction, and the difference here is going to be 17.3 periodic kilonewton. For the moment, I don't have any concentrated moment here. See, point A, no concentrated moment, no change. And then we go to AB, and when we go to AB for the shear, I find this 17.3 value that we have here, and then I have this area. This area, remember, is a negative area because the arrows are coming in this direction that make it negative, and the area is 4 times 6. So it's going to be 17.3 minus 24, which gives a value of 6.6 periodic also, kilonewton. And because this is a negative area, once again, the slope is going to be negative and it's going to be a straight line. So this is going to be 6.6. We're going to reach this point here, negative 6.6 periodic, and this is going to be a straight line there. And now we go to the moment. How do we calculate the moment? Oh, okay. If we're going to calculate the moment by the areas, you have to remember that this is a point that is really important. Why is that point really important? Because the shear is 0. And if you remember the definition of shear, a moment, whatever moment, I know we are not working the integral part, but moment is the integral of the shear multiplied by the x. That means that the derivative of the moment with respect to x is the shear. And whenever I want to find, whenever the derivative is 0, because this is the derivative of the moment, the function is going to be either a local maximum or a local minimum. So that's a point of interest for me, and I need that point. How do we calculate that point? Well, we can calculate that point of the intersection here by geometry. I can just plain and simple I can start here and say, oh, I have this triangle like that, and this is 17.3 periodic, and this is 6.6 periodic. By the way, I insist in the periodic because you have to, when you put in the calculator this number, don't put 17.3 or 6.7, put 17.33333 up to you don't have any more decimal places, because that's going to save you a lot of trouble when you calculate. And this distance is x, and the other distance, if I call this x, this is going to be 6 minus x. And then you can say by geometry that I'm going to do it here, 17.3 is up to x, as 6.6 is up to 6 minus x. And then you solve for x, and x is going to give you 4.3. Meaning this value here is 4.3 periodic, and this other value has to be 1.6 then periodic. Now there's another way which is a little bit easier than this. I'm going to explain it just once, try to understand it because it's not complicated. What I'm going to do is I'm going to displace this line parallel, and this is going to be the 0, right? So I'm going to bring this line parallel to this one, and I'm going to bring it here parallel to this one. And if I do that, this value here is 17.3. That means that at the 0, this is also 17.3. And then I study this triangle instead of studying the other comparison of the triangles. And if I use that triangle, I can say that this value, which is 24, is up to the total distance from here to here, which is 6, as this height, 17.3, is up to this distance that I'm looking for, that's x. And by doing this, you can calculate the x is 4.3. This is a lot easier, or a lot faster at least. I don't know if call it easier. But whatever way you use is okay. So now we have that point there. And if we want to calculate the moment, because this is the part that we were doing here, now I have to include a new point here. I'm going to go, this is A, I'm going to call this A prime. And then for the moment, I have to come here and say, okay, from A prime, I had this value first of negative 56, and that negative 56, then I'm going to add this area, and that area is 17.3. This distance is 4.3, and this is positive because it's plotted above the axis, 17.3, and this is 4.3. When I do this, I get negative 18.4. And at the same time, this value here is going to be negative 18.4 periodic also, and this area is positive and is decreasing because the height is decreasing as I'm running it. So it's positive decreasing. And remember that we have a circle. Please don't neglect infants, neglect dumb people. Instead, positive decreasing is this shape, meaning this is going to be in that shape. There you go. And now continue with A prime B. Because then A prime B, what we have is this value, negative 18.4, plus this area. And that area is a negative area. Remember, 6.6 periodic, and this is 1.6 periodic, and this is negative area. When you do that, you get negative 24 kilonewton meter. So you're going to go up to this point, and this value is going to be negative 24 kilonewton meter. How is going to be the shape? Well, this shape obviously is negative because we already say it, and because the area, the height is increasing, so it's negative increasing, and negative increasing is going to be this shape, and that shape means that this should go like that. We are almost done, guys. Now we go to the point B for the shear, point B. And if we study the point B for the shear, then we have a negative value of negative 6.6, and I have my reaction By in this direction, which is 18.6 periodic. And when you do this negative and this positive, you get a value of 12 kilonewton, positive 12. That means there's going to be a jump here up to 12 kilonewton there. And for the moment, there's no change. You see, there's no concentrated moment, so I continue. Now I go to BD for the shear, and then you get 12 here plus this area, and that area is negative because the arrows are coming down. This value is 4. This distance is 6, and it's negative, so you have 12 minus 4 times 6 divided by 2, which is 0, and you reach the value 0. How is this area negative? The height is getting smaller, so negative decreasing. When you check your circle again, negative decreasing is going to be this shape, so we have to put this shape here, negative decreasing, and you go to that point and you reach your value for 0. Negative decreasing is like that, and you say yes, because you finish your shear in the correct way. For the moment, which is the last one, and with this we finish, then what we have to calculate is the shape, the area of this. You get a value of negative 24 here. Remember, this is BD. You get a value of negative 24, and then this is a positive area, and the positive area is just this type of the parabola, which this is 12 and this is 6. And remember, this is 1/3 of B times H, so it's going to be negative 24 plus 1/3 of 6 times 12, and that's 0. This is positive, this shape, and the height is decreasing, positive, decreasing, and positive, decreasing. This is the shape that I have to use. This is the shape that I have to go and reach there. And this is 0, and then you say yes. And this is a shear moment diagram for a beam that has some components added to it. I know we did it by areas, but you have to explain every single term and every single step of the process. Now I would like you to go and do the same problem by integrals, and do it also by sections so you can compare. See you in the next video, guys. I hope you enjoy. Have a good day.